In this part of the lesson, I'm going to look at plotting solutions from a table. So I'm going to start by looking at tables of values, the same type that Steve used. And I'm going to plot points from these tables of values. I'll end the lesson by looking at an application. So let's start by looking at some tables of values. In the first example, we're asked to plot the ordered pairs in the table and connect them. So it looks like I have 3 ordered pairs in this table. If I'm going to plot them, I need some graph paper. So here's some graph paper conveniently labeled and scaled for me. The first ordered pair I have is 0, 4. So I need to go to 0 on the x-axis and then up 4. And here I am at 0, 4 on the y-axis. This is my y-intercept. Next, I need to plot the point 3, 2. So I go to 3 on the x-axis and up 2. And here's the point 3, 2. Next, I have the point 6, 0. The point 6, 0 lies right on the x-axis. This is my x-intercept. Now I'm asked to connect these points. Well, looking at these points, it looks like they all lie on the same line. Looking at my equation above the table, 2x plus 3y equals 12. This is a linear equation. It has the form ax plus by equals c. So the graph should be a line. So I'm going to get out my straight edge and connect these points. Is the point 3/2 3 a solution to the equation 2x plus 3y equals 12? Well, to answer this, I can look at my graph and see if the point 3/2 3 is on the graph. So 3/2 tells me I need to go to 3/2, which is 1.5 on the x-axis, and then up to 3 in the y direction. And it does look like the point 3/2 3 lies on this line. So I would say, yes, 3/2 3 is a solution to 2x plus 3y equals 12. Let's look at another example. Here we're asked to plot the ordered pairs suggested by the table and connect them. Notice the ordered pairs aren't typed into the table for us, but we can figure out the solutions by looking at this table. In the first row of numbers, I see 0, -3. This corresponds to the ordered pair 0, -3. So I need to get out some graph paper. Again, conveniently, this graph paper is already labeled and scaled for me. So I'm going to go ahead and start plotting the points. I have the point 0, -3. This tells me go to 0 on the x-axis and down 3. 0, -3 lies on the y-axis. This is my y-intercept. The next point is the point 2, 1. So I go to 2 on the x-axis and then up 1. My next point is the point 4, 5. So I go to 4 on the x-axis and then up 5. Again, I'm asked to connect these points. And I can see, looking at these points, that they look like they all lie on the same line. So I'm going to get out a straight edge and connect the points. As I mentioned, the y-intercept is the point 0, -3 that lies on the y-axis. It looks like this line also has an x-intercept, although that's not one of the points that I plotted, and our x-intercept is the point on the x-axis. Let's look at another example. Once again, I'm asked to plot the ordered pairs suggested by the table and connect them. It looks like I have 4 ordered pairs suggested by the table. To plot these, I need a piece of graph paper. The first point that I would need to plot is -3, 10. So I have an x-coordinate of -3 and a y-coordinate of 10. So if I go up 10, oops, I'm off the graph altogether. It looks like I need to start out with a nice blank sheet of graph paper that isn't already conveniently labeled and scaled for me, so I can think a little bit more carefully about the scale. So I'm going to go ahead and start by drawing the axes with my straight edge. And I need to remember to label my horizontal axis, x, and my vertical axis, y. Looking at the x values in the table, I need to plot -3, 0, 3, and 6 for my x values. If I count the tick marks on my x-axis, 1, 2, 3, 4, 5, 6, it looks like I can use a scale of 1 on my x-axis. 1, 2, 3, 4, 5, 6. Where I need to make my careful choice was where I ran into my problem on the y-axis. One of the y values I need to plot is 10. I know if I make each tick mark worth 1 on the y-axis, I'm not going to be able to make it up to 10. What if I went by 2s? 2, 4, 6, 8, 10, 12, that would do it. So 2, 4, 6, 8, 10, 12. Same thing down here. -4, -8, -12. So now when I try to plot -3, 10, and I go to -3 on the x-axis, now I can count up to 10. 2, 4, 6, 8, 10. Here's the point, -3, 10. My next point is 0, 5. My x-coordinate is 0. My y-coordinate is 5. This is my y-intercept since the point 0, 5 lies on the y-axis. My next point is 3, 0. So my x-coordinate is 3, my y-coordinate is 0. I don't have to move up or down. I have a point right on the x-axis. This is my x-intercept at 3, 0. My last point is 6, -5. So I start at 6 on the x-axis and go down 5 to the point 6, -5. It looks like these points all lie on the same line. I'm going to get out my straight edge to connect them. And the line gives me all of my solutions for the equation y equals -5/3 x plus 5. Every point on this line is a solution to the equation y equals -5/3 x plus 5. Now let's find 4 solutions to the equation in this table and then plot them. So my equation in the table is y equals 1/10 x minus 2. I can just randomly pick any x values that I want. I could put in this table 0, 1, 2, 3, 4. But if I look at my equation, I can make a little bit more careful choices. When I substitute a value for x into this equation, I have 1/10 times x. I'm going to have to multiply x by 1/10. I'd rather avoid fractional arithmetic, so I'm going to choose multiples of 10 for my values of x. For instance, I could choose -10, 0, 10, and 20. All of these are multiples of 10. When I substitute -10 for x, 1/10 times -10 is -1. -1 minus 2 is -3. So y is -3. When I substitute 0 for x, 1/10 times 0 is 0. 0 minus 2 is -2. So y is -2. If I substitute 10 for x, 1/10 times 10 is 1. 1 minus 2 is -1. You might be noticing a pattern here. The x values that I chose, which were all multiples of 10, are increasing by 10 each time. I went from -10 to 0, that's an increase of 10, 0 to 10, that's an increase of 10, 10 to 20, that's an increase of 10. Well, look at the y values. To get from -3 to -2, I just add 1. To get from -2 to -1, I just add 1. So if I add 1 more, y should be 0. Let's make sure that really does work. If I substitute 20 for x into my equation, I have 1/10 times 20 is 2, and 2 minus 2 is 0, so it does work. Well, I'm also asked to plot these solutions. This time I'm starting out with a blank piece of graph paper. I want to be careful that when I draw in my axes and choose a scale, that I'm actually choosing a scale that's going to allow me to plot these 4 ordered pairs suggested by the table onto my graph paper. So I'm going to start by drawing my axes with my straight edge. So I'll label my horizontal axis x and my vertical axis y. And now I need to think about the ordered pairs that I'm going to be plotting. Looking at my x values, I have x values of -10, 0, 10, and 20. So I definitely can't let each of these tick marks on the x-axis represent 1. A scale of 1 is just not going to work for me. What if I tried 5? If each of these tick marks were worth 5, I'd have 5, 10, 15, 20, 25, 30, and that's plenty enough space to be able to plot the ordered pairs I need to. So 5, 10, 15, 20, 25, 30. And on the left, -10, -20, -30. Now let's look at the y values. The y values I have to plot are -3, -2, -1, and 0. So definitely a scale of 1 would work along my y-axis. There are other choices I could make as well. I'm going to stick with 1. So 1, 2, 3, 4, 5, 6. And the negatives, -1, -2, -3, -4, -5, -6. The first ordered pair I'm plotting is -10, -3. So my x value is -10. I go to -10 on the x-axis and down 3 units to the point -10, -3. My next point is 0, -2. My x value is 0, so I'll start at the origin, and then I need to go down 2. I have a point on the y-axis. This is called the y-intercept. My next point is 10, -1. My x-coordinate is 10, so I start at 10 on the x-axis and move down 1 unit to the point 10, -1. My last point is 20, 0. My x-coordinate is 20. My y-coordinate is 0. So I start at 20 on the x-axis, and that's where I stay. I don't need to move up or down. So I have a point 20, 0 right on the x-axis. This is my x-intercept. Now I want to go ahead and connect the points that I just plotted. I have the equation y equals 1/10 x minus 2. This is a linear equation in 2 variables. Looking at the points, I see that they all lie on the same line. So I'm going to use my straight edge to connect them. And here we have a graph of y equals 1/10 x minus 2. Now I want to look at an application. After n trips at $2.50 each, a $20 prepaid subway ticket is worth $20 minus $2.50 times n, where n is the number of trips. The equation v equals 20 minus 2.5n gives the amount in dollars remaining on the ticket, or the value of the ticket. Let's complete the following table. Notice in the table I have a column heading for n, the number of trips, and a column heading for v, the value of the ticket. So if n is 1, if we've made 1 trip on the subway, which costs $2.50, we start out with our $20 prepaid ticket, subtract $2.50 times 1, That's $17.50. So V is 17.5. If N is 2, I've made 2 trips at $2.50 each. 2 times 250 is $5. 20 minus $5 is $15. Each of the trips on the subway cost $2.50. The value of the ticket, if we look in our column V, is decreasing by $2.50 each time we take a trip on the subway. So if we take 3 trips, we should just have to decrease 15 by 2.5, which is 12.5. If we take 4 trips, we should just have to subtract 2.5 from 12.5, which is 10. So if we've taken 4 trips, the value left on this prepaid subway ticket is $10. Well, now let's plot the ordered pairs from the table that we've just found. So notice I'm starting out with a blank piece of graph paper. I need to think about my choice for the scales on the axes. Before I even draw in my axes, I want to note that all of the values in this table are positive. So when I make my axes, I'm going to draw this grid so that we see mostly the first quadrant. I'm going to draw my horizontal axis close to the bottom of the grid. My horizontal axis represents the independent variable, the first column of the table, which is the variable n, representing the number of trips. Since I mostly want to show the first quadrant, I'm going to draw my vertical axis close to the left of this piece of graph paper. The variable V is called the dependent variable. The value of the ticket depends on the number of trips. So I'm going to label my vertical axis as the value of the ticket, and that's measured in dollars. Now I need to choose some scales for my axes. For my n-axis, I just need to plot the numbers 1, 2, 3, and 4. So I think choosing a scale of 1 will work on the n-axis. On the v-axis, I need to plot numbers 17.5, 15, 12.5, and 10. Let's see if using a scale of 2.5, since the value is decreasing by 2.5 with each trip, works. So if I make the first tick mark 2.5, the second would be 5, the fourth would be 10, the sixth would be 15, the eighth would be 20, and that gets us past 17.5. So 5, 10, 15, 20, 25. Now let's go ahead and plot the points. So I start with a point 1, 17.5, then 2, 15, 3, 12.5, and 4, 10. Notice that as we look at these points from left to right, which is how we read a graph, the points are going downwards, which makes sense, the value of the tickets decreasing by $2.50 for each trip. So let's go ahead and connect these points. They look like they all lie on a straight line, so I get out my straight edge to connect the points. All of the points on this line are solutions to our equation v equals 20 minus 2.5n. Well, let's use this graph to determine the value of the ticket after 6 trips. So if we have 6 trips, we need to look at the horizontal axis, which represents the number of trips. So if I locate 6 on the n-axis, move directly up to my graph, it puts me at this point. What I need to figure out is, what is the second coordinate of this point? The first coordinate is 6. The second coordinate, I need to look over to the vertical axis. So if I move directly left from this point, that would put me at 5 on the vertical axis. So I have the ordered pair 6, 5. So what does this tell me? The value of the ticket after 6 trips is $5, the value that we read off the vertical axis. Well, let's look at this graph a little bit more. Which ordered pairs on this graph make sense in the context of the problem? Well, thinking about this problem again, we're thinking about V being the value of the ticket and N being the number of trips. Now, I can't take a fraction of a trip, so I can only think of integer values of N. I also can't take a negative number of trips, so I can only think about non-negative integer values of N. Taking that into consideration, we could look at the point where N is 0, the point where N is 1, the point where N is 2, 3, 4, 5, 6, 7, and 8. If I go beyond the point where N is 8, now my value is becoming negative, which doesn't make any sense. If I have a negative value of the ticket, I don't have anything left to ride the subway with. I need to buy a new ticket. So there's actually only 9 ordered pairs that make sense in the context of the problem. When we look at the graph of V equals 20 minus 2.5n, there are only 9 ordered pairs that make sense in the context of the problem. The line that's graphed when we look at V equals 20 minus 2.5n gives all of the solutions. There's an infinite number of solutions to the equation V equals 20 minus 2.5n, but only 9 of these solutions make sense in the context of the problem. What is the vertical intercept on this graph, and what does it mean in practical terms? Well, let's recall that the vertical intercept is the solution to the equation of the form 0 v sub 0, since our vertical axis is labeled v in this context. Another way we can think of this is the vertical intercept is the solution on the vertical axis. So I need to look at the point on the vertical axis. That looks like the point 0, 20. So my vertical intercept is 0, 20. Well, there's actually 2 parts to this question. The other part asks, what does it mean in practical terms? Well, now we have to think back to the context of the problem. The first coordinate of my ordered pair is my n coordinate, and the n value tells me the number of trips. So when we see an n value of 0, we're talking about 0 trips. The second coordinate of my ordered pair, the 20, tells me the value of the ticket. So that tells me when I've taken 0 trips on the subway, the value of the ticket is $20. So to answer both parts of this question, the vertical intercept is 0, 20, which means that when you have taken 0 trips on the subway, the value of the ticket is $20. Well, let's look at one more problem related to this graph. What is the horizontal intercept, and what does it mean in practical terms? Well, let's recall that the horizontal intercept is the solution to the equation of the form n sub 0, comma, 0. N in this case because our horizontal axis is the n axis. Another way we can think of this is that the horizontal intercept is the solution on the horizontal axis. So I need to look for the point on the horizontal axis. And that looks like the point 8, 0. To be able to answer the second part of the question, what does this mean in practical terms, again, I need to think about what do the coordinates in this ordered pair represent. The first coordinate, the 8, is my n value. That's the number of trips. So we're talking about 8 trips on the subway. The second coordinate of the ordered pair is the v value. That's looking at the value of the ticket. So a v value of 0 means that the ticket is worth $0. We've used up the ticket. So let's answer both parts of the question. The horizontal intercept is 8, 0, which means that if you have taken 8 trips on the subway, the value of the ticket is $0. That concludes lesson 13.